Okay, we're going to look at an exercise from the book called Functions from Graphs. Now, this involves identifying the equation of a function by looking at its graph and specifically its roots. Now, if we think, for example, if we've got a parabola and a root at 2 and a root at 3, then it seems to be a reasonable assumption to say that that would come from the equation y equals x squared minus 5x plus 6. The reason being is that if I factorise to solve there, that will be x minus 3 bracket x minus 2 is equal to 0, which in turn will give me roots at 3 and 2, and that appears to be true. However, there's more than one curve which we could draw, which will go through 2 and 3, so I'm drawing multiple curves here, multiple parabolas that go through 2 and 3, but they're all of different shape. So how can we say definitely that the original one that went through 2 and 3 comes from this particular equation? Because in practice there's an infinite amount of curves that could be drawn that go through 2 and 3. So that's the problem that we're going to be solving today. Now we're going to look at it with parabolas there. So that's when we've got one turning point, but we're also going to be looking at when we've got more than 2 roots, potentially 3 roots. So let's try and solve that problem and look at an example 1. Okay, so example 1, we've got a parabola that goes through minus 3 and 2 on the x-axis, that's the roots, and it cuts the y-axis at minus 12. So again, it is a reasonable assumption to say that that comes from the function x plus 3 in a bracket, x minus 2 in a bracket, because that would give me a root of minus 3 and a root of 2, as we can see from up here. However, as discussed, how do we know that that's the exact function, given the fact that there are an infinite amount of curves that could pass through minus 3 and 2? So what we do at that point is we put a proviso in front, which is k, and we need to find that value of k. Now the question will give me a clue. Now the clue in the question is that the curve also passes through the y-axis at minus 12, and that is the point 0 minus 12. So when the x-coordinate is equal to 0, the y-coordinate is equal to minus 12. So I'm just going to say that again. When the x-coordinate is 0, the y-coordinate is minus 12. When the y-coordinate is minus 12, the x-coordinate is equal to 0. And I've just made that substitution in there for y, x, and x again. When the y-coordinate is minus 12, the x-coordinate is 0. Okay, so that's 0 plus 3 multiplied by 0 minus 2. So that's 3 times minus 2 times k. So 3 times minus 2 is minus 6 times k is minus 6k. K is then equal to minus 12 over minus 6. And k is equal to 2. So the final function then, we know that the proviso of k is now equal to 2. So it's 2 bracket x plus 3 bracket x minus 2. We'll try another few of those. Okay, so let's try another one where we've got a curve with more than one turning point. Okay, so this time we've got a root at minus 2, a root at 1, and a root at 5. And we're also told that the curve passes through the y-axis and has a y-intercept of 30. So a root of minus 2 will come from the bracket x plus 2, a root of 1 will come from the bracket x minus 1, and a root of 5 comes from the bracket x minus 5. Let's put the proviso in front, and y equals. Now the clue is that we've got the point 0, 30, so when the x coordinate is 0, the y coordinate is 30. When the x coordinate is 0, the y coordinate is 30. Okay, so let's just take our time with that. 0 plus 2 is 2, times 0 minus 1 is minus 1, times 0 minus 5 is minus 5, so 2 times minus 1 is minus 2, minus 2 times minus 5 is 10, times k is 10, k is equal to 30 over 10, and k is equal to 3, so the final answer then for the function is y equals 3 bracket x plus 2 bracket x minus 1 bracket x minus 5. Okay, let's try another. Okay, so we've got a root at minus 1, a root at 3, and a root at 4. We pass through the y-axis at 12. Okay, so that then is the point 0, 12. So a root at minus 1 comes from the bracket x plus 1, a root of 3 coming from x minus 3, and a root of 4 coming from x minus 4. Let's put the proviso in front, and y equals. Okay, so the clue is that when the x coordinate is 0, the y coordinate is 12. So when the y coordinate is 12, the x coordinate is 0. Okay, so 0 plus 1 is 1, multiplied by 0 minus 3 is minus 3, multiplied by 0 minus 4 is minus 4. 1 times minus 3 is minus 3, times minus 4 is plus 12. So 12 equals 12k, k equals 12 over 12, and k is equal to 1. So the final function then is 1 bracket x plus 1 bracket x minus 3 bracket x minus 4. We don't need that one at the front, so just write it as x plus 1 bracket x minus 3 bracket x minus 4. Okay, let's look at another. Okay, this time we've got a root of minus 4. We've got equal roots, crucially, to, and that'll adjust things, and we're passing through the y-axis at 48. Okay, so a root of minus 4 comes from the bracket x plus 4. Now we just need to think about this one. That denotes equal roots, which means I must square the bracket. So when we go right through a root, it's just the linear bracket, but if it's equal roots, which is denoted by going up, hitting the axis and coming back down, or going down, hitting the axis and going back up, like so and like so, we must square the bracket because that denotes equal roots. Okay, so we would square the bracket for an example like that or that, but not square the bracket in examples like that. So just a normal bracket for what's going on here, but squaring the bracket here with a proviso k at the front. Okay, so we're passing through the y-axis at 48, so that's the point 0, 48. When the x-coordinate is 0, the y-coordinate is 48. When the y-coordinate is 48, the x-coordinate is 0. Okay, so take your time. 0 plus 4 is 4. That's multiplied by 0 minus 2 is minus 2. But minus 2 squared is 4. 0 minus 2 is minus 2. Minus 2 squared is 4. So that's 4 times 4 times k, which is 16k. K is equal to 48 over 16. K is equal to 3. Final answer is 3 bracket x plus 4 bracket x minus 2 all squared. Okay, let's try another. And this time we've got equal roots at minus 2. We've got a root at 4 and we're passing through the y-axis at minus 32. So the root of 4 comes from the bracket x minus 4. Equal roots at minus 2 comes from the bracket x plus 2 all squared, with the proviso k at the front and y equals. We've then got our clue, which is cutting the y-axis at 0 minus 32 when x equals 0, y equals minus 32. So let's throw that in. Okay, so 0 plus 2 is 2. 2 squared is 4. Multiplied by 0 minus 4 is minus 4. So 4 times minus 4 is minus 16 times k is minus 16k. K is equal to minus 32 over minus 16 and k is equal to 2. So final answer then will be y equals 2 bracket x plus 2 all squared bracket x minus 4. Okay, and another one. Okay, we've got equal roots at minus 2 and equal roots at 2. We're passing through the y-axis at minus 48. So the full point then is 0 minus 48. So equal roots at minus 2 comes from the square bracket x plus 2. Equal roots at 2 comes from the square bracket x minus 2. So again, that's because they're not passing right through, but it's parabolic at the x-axis. So either going up hitting the x-axis and down, or it would be equal roots if it did similar but going down and coming back up. Okay, with k at the front and y equals. When the x coordinate is 0, the y coordinate is minus 48. So let's sub that in. When y is minus 48, x is equal to 0. Okay, so 0 plus 2 is 2, 2 squared is 4, multiplied by 0 minus 2 is minus 2, minus 2 squared is 4. So 4 times 4 is 16 times k is 16k. K is equal to minus 48 over 16, k is equal to minus 3. Final answer then is y equals minus 3 bracket x plus 2 all squared bracket x minus 2 all squared. Okay, we're going to try one final example. Now you may have noticed that every time we've looked at one of these questions, the clue that you've been given in the question in terms of an extra point has always been on the y-axis, but that doesn't necessarily need to be the case. So we're going to look at one where that is definitely not the case. So we've got a root at 1, 4 and 6. Now instead of being given some information on the y-axis, we're not this time, we're given some extra information, which is just another point, which this time is 5, 8. So this time we know that when the x coordinate is 5, the y coordinate is 8. So a root of 1 comes from x minus 1, a root of 4 comes from x minus 4, and a root of 6 comes from x minus 6. It's not equal roots for any of these, they're just going straight through. So no square brackets, a k at the front and y equals. So the clue being this time that when x equals 5, y equals 8, so let's sub that in. Okay, so 5 minus 1 is 4, 5 minus 4 is 1, and 5 minus 6 is minus 1. So 4 times 1 is 4, times minus 1 is minus 4, times k is minus 4k. K is equal to 8 divided by minus 4, k is equal to minus 2. Final answer then will be y equals minus 2 bracket x minus 1 bracket x minus 4 bracket x minus 6.